Algebra 2 Honors, Lesson 2-1, Relations and Functions. Here are the lesson's objectives. Key vocabulary. The first one, relation. A relation is a set of ordered pairs. For example, right here, this is a relation. It's just a bunch of random ordered pairs grouped together. Right? Now, the x values in the relation are considered the input values, also called the domain. Okay? The y values are the output values, also called the range. Okay? Now, the next key vocabulary is the word function. Okay? Now, a function is a relation where for every x, there is only one y. Right? Each domain is paired with exactly one range, meaning x cannot repeat. Right? In a function, the x value cannot repeat, but it's okay for the y value to repeat. For example, let's say we have 2, -3, 4, -1, 0, -3, and 2, and 0. Now, this right here is a relation. Now, is it a function? Right? Well, you have to look at the x values. If the x value never repeats, it's a function. But you see in this case, the x value right here, the number 2, it repeats. So this is not a function. Right? Now let's think of another one. Let's say we have 1, -4, -2, 1, 0, and 1, and 5, and 1. Now let's take a look at the x values here. We have 1, -2, 0, and 5. They're all different. Okay? Since x never repeats, this is a function. Alright, this is considered a function. Now you notice here the y value repeats. Alright, but that doesn't matter. It's okay for y to repeat, just not x. Okay? So let's do a few examples here. So does the relation make a function? Right, so let's take a look at all the x values. 2, 3, -4, 5, 1, and 0. Right, it doesn't look like x ever repeats, so this is a function. Number 2 here, right, I notice 3 repeats, so this is not a function. Right. There you go. So write the ordered pairs for the relation. Find the domain and range. So during your homework, you're going to have a few problems where they're going to give you a graph. Basically, to write the ordered pairs, you're just finding the ordered pairs for these points. Right? So for example, right here, let's find this first ordered pair. We have -4 and 4. Right, for this point right here, we have -3, -2. For this point right here, we have -2 and 4. For this point right here, we have 2 and -4. And for the last point right here, we have 3 and 2. Right. So now let's take a look at it. Right. Find the domain and range. Right. Remember the domain are the x values. Are the x values. So the domain in this case would be -4, -3, -2, 2, and 3. So we have -4, -3, -2, 2, and 3. The range are the y values. In this case, it would be 4, -2, 4, -4, and 2. So 4, -2, 4, -4, and 2. Okay? Number 3, make a mapping diagram for the relation. Okay? Basically, a mapping diagram, what you're doing is you're going to list out the domains and the range. Right. So we have -1 here, so that's a domain. We have 1, okay? Then we have 1 again, so it's already here. Then we have -1. So those are all our domains. Now for the range, remember those are the y values. We have 7. We have 3. We have 7 again, right? And we have 3, right? And then a mapping diagram, we're just going to map them together. So -1, right, goes with 7. So -1, right, goes with 7. We have 1 goes with 3. Then you also have 1 go with 7, right? And then -1 goes with 3, right? That's a mapping diagram. Now, the vertical line test, all right? Sometimes, all right, you'll be given a graph, and they're going to ask you, is this graph, all right, whatever diagram is on the graph, is it a function, right? And to determine if a graph is a function, right, what you're going to do is you're going to use the vertical line test, right? And this is how the vertical line test works. Basically, let's say you have a diagram here, okay? If you draw a vertical line, right, through the picture, does it ever touch, right, the picture at more than one point? If it does, then it's not a function. Like in this case, right, our vertical line touches 3 times, so we know that this diagram, this graph is not a function. Right? Now, over here, you're going to notice if you draw vertical lines, right? If you draw vertical lines throughout the whole, diagram, picture, it will always only touch at one point. Okay? If it touches only at one point throughout the whole picture when you're drawing different vertical lines, it is a function. So this is a function. Right? So this is a function. Okay? Now keep in mind here though, I know right here when you draw a vertical line, it touches 3 times. Alright, let's say you had drawn the vertical line just through right here, and you can say, well, it only touches 1 time. But you have to consider the whole graph, the whole diagram. If you draw another vertical line right here, it's going to touch 3 times. So this is why this is not a function. Okay, you have to consider the whole picture, the whole graph, and not just one specific portion of the graph. Alright, so let's use the vertical line test. If we draw a vertical line down right here, oops, it touches 2 times, this would not be a function. Over here, if you draw a vertical line, it only touches once, draw a vertical line, it touches once, a vertical line, it touches once, a vertical line, it touches once, this is a function. Okay. Now right here, let's draw a vertical line. You notice it touches 2 points already? Alright, it's not a function. Okay, it's not a function. Alright, so let's say it had passed that point, you would check all these other points. Okay, remember it can only touch, the vertical lines can only touch, at one point. Okay, and I know my vertical lines are terrible, but oh well. Alright, the last thing, function rules. A function rule expresses an output value in terms of an input value. Okay, now these are 3 separate function rules. Alright, just giving you different examples of function rules and how they can be written. Okay, it can be written with the letter y. Alright, y is equal to 2x. Alright, Now y is considered the output value because depending on what x is, x determines, right, what y will be. For example, if x is 1, y is going to equal 2. If x is 2, y is going to equal 4. That's what x is the input value. Whatever you put in for x, right, will determine what the output value, what y will be. Right? Now sometimes instead of using y, they will use the notation, right, f of x. Alright, this notation right here is read, alright, f of x. Okay, it doesn't mean f times x. Alright, this means function, alright, f of x. Okay. Now once again, x is the input value, alright, and f of x is the output value. Right? Now you might have an equation, a formula. Right? For example, right, the circumference equals pi times diameter. Right? This formula here is also a function, right? Because the circumference depends on what the diameter is. Right? Now the input value here in this case would be d. Right? If the diameter changes, the circumference will change. Right? So d is the input, and so the circumference c is the output in this case. Okay. Now let's take a look at some examples. Now down here, alright, you're given a function. Alright, you're given a function. Now they want you to evaluate the function for f of negative 3. Alright, so if you have something written like this, alright, that's how it's read. F of negative 3. It doesn't mean f equals negative 3 or f times negative 3. That's incorrect. It's read f of negative 3. Alright, so they want you to evaluate it for f of negative 3, f of 0, and f of 5 for each function. Alright, I'll do the first one, and I think you guys will get the point. Alright, so basically all you have to do is you're just plugging negative 3 in for x. So here's the function f of x is equal to 3x minus 5. So if you're gonna check f of negative 3, so f of negative 3, what you're gonna do is wherever there's an x, you're gonna plug in negative 3. So it'd be 3 times negative 3 minus 5. Obviously this is going to equal negative 9 minus 5, so we get negative 14. Alright, so f of 0, so instead of x here, we're going to plug in 0. So 3 times 0, minus 5, well, that's going to equal negative 5. Then the last one, f of 5, so for x, we're plugging 5, 3 times 5, minus 5. Alright, so we get 15 minus 5, we get 10. Okay, so basically for these other examples, you're doing the same thing. Go ahead and find f of negative 3, f of 0, and f of negative 5. Alright, and that's it.